If I'm solving using a TI graphing calculator, I'm going to put in the y equals and put in both of my equations that I have substituted in. I'm going to put y1 is going to equal my first equation, y2 is going to equal my second equation. Then when I'm in the graph, I'm going to do the second trace and find the intersect point. So when I do that intersect function, it's going to look for where the two meet. It will say first curve, which means pick the first line. You can just hit enter because you're only going to have two equations in here. Second curve means the second line, hit enter again because it's going to be there. And then when it says guess, that's going to be more important when you get to 20-1 or 20-2, where it's going to have multiple points where they cross. In this case, they're only going to cross in one spot, so you can just hit enter again, and it will take you to the exact coordinates for where this works. So, if I'm going to consider the system of equations from the exploration at the beginning, I'm going to rewrite each equation in slope-intercept form, which we've actually already done. And I'm going to state that the first equation, which I'm going to call y1, is going to equal negative 3x plus 11. And I'm going to state that y2 is going to be that simplified form of negative 2 over 3x plus 4. I'm going to graph it into my equation. I need to state a suitable window, which means that I should be able to see where everything crosses. I definitely need to see the intersect point, but I should also see all of the x and y intercepts for both equations if I've done it properly. So in this case, I'm going to state that my x ones, so that I can see everything I need to, can be negative 5, 10, and 1. And my y values are going to be a minimum of negative 10, going up to 15, and then I can say that they have a scale of 2. When I use that intersect feature, I see that they cross at 3 and 2. If a decimal appears for the x under y coordinates, then x under y can be converted to an exact value as long as it is not irrational. And we're not really going to run into irrationals this year. More so, we're going to see it next year. So, if I'm doing that, I can use these functions to copy my answer over, and then I'm going to use the convert to a function choice. So, if it wants me to solve these two cases, then I'm going to state that one of these values is going to be x and one of them is going to be y. I'm going to state that A is going to be x and B is going to be y, because I can only graph in terms of x and y. Then I'm going to take my first equation and say, well, if my first equation is 6x plus 7y is equal to 5, then 7y is going to equal negative 6x plus 5, or y is going to equal negative 6 over 7x plus 5 over 7. And I'm going to call that my y1. That's what I'm going to graph into my calculator. For my y2, I'm going to state that, well, if 3x is equal to 14y, then 14y would equal 3x, or y would equal 3 over 14x. And that's going to be my y2. I graph them out on my calculator, and I'm going to see that I have my first case should look something like this. That's going to be my y1. My y2 is going to look something like this. And then I can see when I do the intersect that they're going to cross exactly at this point. Now, when I list the exact value of those using the turn into a fraction function above, it's going to tell me that this is going to cross to the point of 2 over 3 and 1 over 7, which means that given my information up here, a is equal to 2 over 3, and y is going to equal 1 over 7. If I need to algebraically verify the solution, I'm going to do that same substitution method we did in the last case. I'm going to say that 6 times 2 over 3 plus 7 times 1 over 7 is equal to 5. And here's my equation 1. 6 times 2 is going to be 12. Divided by 3 is going to give me 4. 7 times 1 is 7. Divided by 7 is going to be 1. And 5 does equal 5. For equation 2, if I have 3 times 2 over 3 is equal to 14 times 1 over 7, then 3 times 2 is going to be 6, divided by 3 is going to give me 2. 14 times 1 is 14, divided by 7 is going to be 2. 2 equals 2, and both these solutions work.